Hello, everyone. We should be going live. Can someone check in the chat that everything is working? Oh, okay, we're live. Thank you very much. My name is Alberto Salgado. I will be just monitoring the talk. So if you have any question or anything, just drop it in the chat. I will be keeping an eye to let Jonathan know. And here, let me present you Jonathan Vila, Joke leader from Barcelona and a dear friend to me. And he will be explaining us that, well, Java is still a very valid language in the cloud and that the rumors about its death are greatly overstated. Go on.
Thank you very much, Abel, for introducing me. And well, welcome everyone to this presentation. I hope it's going to be a bit fun, interesting, or somehow that you are not going to waste your time. Here, what I'm going to show you is we are constantly hearing that Java is dead again, and recently, I've had the opportunity of creating things for the cloud. And the first impression that you get when you go to the cloud, at least in my experience, was that, there are several languages there that apparently have, a lot of tradition of being there in the cloud. So is it Java the right tool or language or to use it for going to the cloud? My first experience was deciding the language for creating an operator, Kubernetes operator. And I would say that the easiest way, or the way that was more used to, or that I could find more information on, was use Go. But I said, man, again, I need to learn a new language. Is it really worth it? Is it because Java cannot go to the cloud? So I tried to use Java, and I'm happier than ever. So let's go to the presentation, and let me show you what were my findings in this experience of starting with using Java in the cloud and comparing with the other languages that, sometimes can make you a bit unconfident of where you are. So let's begin. I'm going to share my screen. Let's hope that everything is fine. Hopefully you are seeing the gray schools fort and a person that it is a bit aged. So by the power of Java, some of you that probably were born on the 70s were watching these cartoons when you were young. So this was for me like something very touchy. So it's not by the power of preschool, but it's by the power of Java. And in this case, it's not the master, the main of the Cloud-ivers. So I will try to convince you that Java is the one. And by the way, Java is not yet dead. So who am I? Well, I'm obviously a Java champion. That's why I'm here. I'm co-leader at the Barcelona Java user group and also co-founder of JVC and Conf, a conference that we host in Barcelona every year. And we are going to do it physically this year, this 2022 in July in Barcelona. So if you don't have anything better than in summer, Barcelona, beach, good weather, good food, and technical event, just go to the conference. By the way, call for paper is open, tickets are on sale, and also we accept sponsorship requirements. And by the way, I'm working as a software engineer at Red Hat, and now in the cloud and the Key Cloud team in the cloud native distribution sub team. Here you have some ways to reach me in Twitter. You can follow me. Sometimes I tweet about experiences that I have with code. Not always are good experiences, but I think everything counts. My email, if you have any questions, my blog, where you can find posts about test containers and amazing technology to do tests as if you were in production. That's the title of another presentation from me. And you can find here also my GitHub account with all the code of my Red Hat projects and also my personal projects. And by the way, that guy that is being used as a Picasso, it's me. So let's talk about motivation first of this presentation. Then I will try to move our mind to give you a bit of context of which are the languages used in the cloud, what are the characteristics of those cloud applications. And when we start taking a look at languages, I would say, one of the main things, in my point of view, is to see which is the community of people that is behind using this language, and also how many repositories are there. Just because the more repositories, the more libraries, the more tools, the more options to do the same thing. So in the end, it's a way to ease your coding experience. Then I will focus on two languages, Go and Java, just because my experience when I started with this cloud trip was that Go was mainly used. So I will focus on this particular approach. So let's see about performance, because that's another criteria to select which is the language that you have to use, right? If it's really performance-wise, is it really worth it? Then, as I'm going to introduce you to Java native, so let's see which are the flavors. So how you can go to Java native. Once we are having this, the whole context of applications going to the cloud, let's go a bit deeper. So, okay, now you can agree with me that you can go to cloud, but can you show me some examples of things that I can do in the cloud? That's the part that I will start showing you. Kubernetes application development, container build and deployment, an application into to have a regular Java application going into cloud. Is it complex, or does it involve a lot of work using YAML or other amazing languages or formats? Then another, I would say, for me at least, another clear indication of how healthy is a language in the cloud is also how many operators are created using this language. And I will show you an example of operator that we are creating it now in Keycloak. It's a POC, but yeah, it's for give you a bit of example of how complex is an operator. By the way, if you want to know exactly how it is to create an operator in Java, I have another presentation. I will also give you the link where I can explain my experience creating an operator. Then, another fancy thing that I discovered when I was using things in the cloud is, you usually use, kubectl or OC if you are in OpenShift. But with kubectl, it's a super powerful command But sometimes you want to do some things that are not in the out-of-the-box kubectl. So there are kubectl plugins, and there are several. And even there are central repositories where you can just simply install them from there in a transparent way for you. And just to finish, I will give you my conclusion. It's my conclusion, nothing else. And also a bit of references and thank yous to the people that have helped me directly or indirectly to this presentation. So let's ramble. Okay, so in terms of motivation, so I had some questions when I decided to create the first operator, and I needed to, to show to my team lead, okay, these are the options. So I needed to answer these questions. For me, one important thing is, does the team need to learn a new language to go to Kubernetes? If you have a good expertise and good skilled people using Java in your team, going to another language, well, it involves time, and it involves that you are not going to be as productive as with Java in this case, but it also that you can end having some approaches that probably are not the best ones, because that is what you have when you are years working with the tool. Now it's Java, but it could be another one. But then another question was, are there any Kubernetes areas where Java cannot work? So let's imagine that I can do several things in Java, but there are two things that cannot be done with Java. So that will involve someone in the team to learn that language. So that's also a tricky thing. If we agree that both first two questions, the answer is yes, then if we use Java, okay, we can go, but is performance-wise, is worth it? Or is it that with Java, yeah, I can do several things, but then, well, my application takes forever. Then that's a totally no-go to use Java. And is Java a language with enough Kubernetes ecosystem in terms of, do I have all the libraries and tools in order to go to Kubernetes, or even that it is super fast and performance-wise is okay, all the areas can be covered with Java, so my Java team doesn't need to learn a new language? Okay, that's a win. But it could be that Java doesn't have libraries to connect to Kubernetes, or that I have to create some things, I need to do lots of things on my own. Then again, it's something that has to be taken into account. So in order to try to answer those questions is why I decided to do a bit of investigation and discovery. And this is what I'm showing you in this presentation. So first thing, which are the languages in the cloud? And you could say, come on, man, I can put almost any language in the cloud. And you're right. So you can have any application created with almost anything, package it, put it in a container, and deploy it in the cloud. That's true. I'm not focusing on that. I'm focusing if you want to go beyond that. So let's imagine that you want to interact with the cluster. Let's imagine that you want to do some automated things in the cluster. In this case, I focused on, okay, taking the official Kubernetes client library, which are the languages offered. So I found that there are, well, basically these five languages: Go, Python, Java, JavaScript, and C#. Basically, the Python one, is the one that has the most forks and the most stars. So we could say the Python Kubernetes Client library is the most used, right? Java comes after that, then JavaScript, then C#, and then Go. Well, this is only a number, but it's starting to give us an idea of which is the ecosystem in Kubernetes. Let's move to Kubernetes Operators. So which are the languages that people are using to create Kubernetes operators? Well, definitely Go here is a winner. So around 1,400 operators created using Go, around 200 with Python, and 76 with Java. But I would say Java operators evolution is going higher and higher. And I would say that with the Java operator SDK, it's gonna gain even more and more adopters. So I see a clear potential here in Java. And also the library is not the less used. There is a lot of people using this Java library. In terms of cloud applications, okay, you can put any Java application, as we said, in a container, running in the cloud. That's it. Okay. Let's imagine that we want to be like or have an enterprise view of the cloud. Then we are going to, let's say, go in favor of applications that are starting super fast and that they have low memory footprint. Why? Well, why? Because the more applications that you can have in a cluster, so the higher cluster density that you can have, let's say that the less money you are going to pay to the public cloud provider. So if where with Java traditional, I can have 10 applications in my current public provider space. If I go to another approach and then instead of 10, I can have 500. Okay, then I'm going to pay more or less the same, but I'm going to have more power because I have more applications doing the same thing. So I can scale up and down based on the need of the application. That's also very important if you want to go to serverless. Fast startup and low memory footprint is super important in this. So just taking a comparison made by Igor in his post, comparing Java, so something that you compile and you do Java, jar, whatever, then you see, well, more than 4 seconds to start compared to the other options. Obviously, .NET is still a lot, but then we have Go, Rust that are very low. So this is, well, like a no-go. If I need faster startup, definitely I have other options better than Java. But here in orange, we have one thing called GraalVM. So if I use certain frameworks that allow me to compile my application made in Java into a GraalVM artifact, a native artifact, then I'm reducing from more than 4 seconds to 500 milliseconds. Well, compared to the 300 milliseconds in Go, well, definitely Go is faster, but we are moving in an order of magnitude very, very similar. And some tweaks in an application can make a big impact in time. So in this case, okay, this GraalVM option definitely is making Java to be a very important option into the, let's say, cloud environment when we focus on performance. Okay, that's a good thing. So then we can use Java definitely to go, in terms of performance, to go to the cloud. If we think about communities, well, just only taking GitHub repos, we are having 4 million repos in Java. Compared to Python, is half of that. But Go is way far from that. So it's 286,000. So there are lots of repos in Java. That's a very good point, right? If we have two surveys from JetBrains or Stack Overflow in terms of usage of one language, well, Python is more used in both surveys. But Java is not far from that number. So taking the JetBrains usage, the number is more or less the same. I know that some of you are doing a sum just to say, okay, that doesn't sum 100%. That's right. Just because one person can use several languages. Gotcha. Okay, so we are having a big number on Java compared to Go, for instance. So definitely here, Go is the loser. So that's also another good point in terms of Java. So that's community and amount of code wise, very strong point in Java. Let's take an example, again from Igor, comparing performance between Java and Go. So in this case, we have three options. In this case, with a Quarkus application, but Quarkus with JVM, it is starting, in that example, more than 1 second. Quarkus native is starting in 17 milliseconds. And Go says, well, it's almost instant. That's fine. Go still wins to Quarkus native, but 17 milliseconds is not that bad, right? And remember that for this case, but for other approaches similar to Quarkus, I can say it's the same. In order to go from Quarkus JVM to Quarkus native, it's a matter of adding -p native in the command line. That's it. You don't have to touch anything in your code. So that's very interesting because now we can see numbers of comparison between Go and Quarkus native. So definitely Java is something to consider in terms of performance. Even in memory, Go wins. That's fine, but it's not, let's say, a race. It's a comparison where we can see that 17 milliseconds at 50 megs of RAM compared to 13 megs of RAM and instant, probably, even it is worse, probably it still is a choice when we go to the cloud. In terms of Java native flavors, well, we have Elidon, we have Micronaut, we have Quarkus, we have Spring. Those projects can convert your application using GraalVM from Oracle, and then you can obtain a native artifact that will have performances similar to the numbers that I've shown before. There are different ages of the frameworks, different people working on them, but I would say please check them because they are very interesting options in terms of doing a high jump in terms of Java, because you work with Java, your loved Java, your traditional Java, your whatever Java. And then if you are using those frameworks and the constraints that those frameworks apply, then you can go to native with no effort. So that's also an amazing environment. Okay, so now you have, well, a bit of idea. I've shown numbers, performances, communities, code. Well, so now let's see some examples. So for instance, let's imagine that you have an application, you want to deploy it to the cloud, to a cluster. Traditional approach is, okay, I do my application, I create some YAMLs, I do kubectl apply or create or whatever, and then I have everything deployed. Then I change my application, I change the conditions, I need to change the YAMLs, I need to do kubectl apply. That's the process, that's the loop. And we all know that we love as the most loved things in our life to work with YAML. So is there any other option? Well, I'm happily introduce JCube, an open source project that will make all that boilerplate for you. So you simply create an application, you add JCube in the dependencies, and it will provide the Maven goals just to generate the resources, to build, to deploy to the cluster, and even to push the image generated to a registry. And one important thing, you don't even have to have Docker installed in your machine. So it will create the image. It supports different drivers, Docker, Podman, whatever. It will create the image without having you Docker installed, using Zip from Google, and you will have your image. So now let's see if I can share, stop share, and I will share. Okay, I think it's this one. Is this one? Yes. Hopefully you are seeing an VS Code application. Well, this is an example from JCube, very easy. So there are 3 Java classes. This is a this is a Pojo register for reflection, because this is a Quarkus example. We have here a REST resource that is doing basically not fancy thing. So it is calling cool the service and get cool application. And yeah, this is what it is returning. Okay. Here, I don't have anything from Kubernetes. No file, just simply a REST application. Okay, so if I go to the Maven package, easy. So what do I expect to have when I do this? Okay. Oh, by the way, first, I will show you that I'm not doing any break. Okay. So here we have this Maven Quarkus created 2 hours ago. Okay. So now let's do the Maven package. Now it's doing it's magic. Okay. So if I do, okay, so it has created an image 11 seconds ago. So it's, wow. But I haven't done anything with the Kubernetes. So everything is on the JCube side. So now let's try another thing. If I do Maven Kubernetes resource and apply, because I already have Minikube running. So, well, first let's check which is my default namespace. So, okay, get all. Okay, I have this this pod. Let's remove it. Oh, sorry. Deleting. Okay. And now I can delete the service. So I only have this service. Sure? Okay, so let's do the creation and the apply of these. So now it's going to create several files. As you can see here, this kubernetes.yaml that it is right now here in the target, that it has all the YAML to deploy the service, the deployment. So it has created the resources, but now if I, wow, now it has deployed the pod, it has created service, it has created a deployment, a replica set, but I haven't done anything with Kubernetes. So everything is on the JCube shoulders. So that's awesome because, yeah, it's abstracting two complexities from me. First, I don't do anything with image containers, so container images, and I don't do anything directly to create those files of those YAML files. It is, let's say, error unprone because I'm not handling directly the YAML files. So as you can see, it's very easy now to create applications that have to be deployed on the cluster because everything is abstracted from me. Container image creation, creation of the YAML files representing the objects, and deploying those resources into the cluster. That's magic. So let's continue sharing the presentation. So now another point is, okay, but what if I want to interact with Kubernetes? So I need a Kubernetes connection. Okay, there are basically, that I'm aware of, two main Kubernetes clients. One is let's say the official one, Kubernetes client, and then there's another one from Fabricate that it has, well, some features added to the standard one. So it has a Kubernetes client, it has an OpenShift client, it has extensions for Knative, Tekton, Istio, and other tools. Even it has a CRT YAML generator. So for those of you that already know what are the CRTs, well, in this case, the client is gonna take all the Java representations, so the classes, the POJOs, and it will generate the CRD for you. Again, it is helping you to do that. There is one person that it is asking me to share the Quarkus deployment YAML. If you don't mind, I will answer the questions at the end. That it is not to break my mojo. So it is abstracting us from generation of the YAML files, and it is even having a Kubernetes API mock for testing. So when you want to go to test your operator, your interaction with Kubernetes, either you can connect to a real Kubernetes, or either you can connect to a mock. So the client is providing a mock with even a CRD or CRUD, a CRUD feature that will make that all your requests to that Kubernetes mock are going to have an automatic response. So for you, it's like you are living in a Kubernetes, but you are not leaving your test. So you are isolated. That's very convenient for testing. Also, it provides watchers, shared informers. So it provides lots of functionalities to interact with Kubernetes. In terms of creating Kubernetes operators that are going to use a Kubernetes client, well, there are several options in the languages that I'm covering in the presentation. So in the end, a Kubernetes operator is an extension of the Kubernetes API where you can create an object called, I don't know, football club. I don't know, a store. Those are concepts that are not obviously created inside Kubernetes, but that can represent something for you that will trigger some tasks after that. So to do that, either you do it manually without an SDK. Yes, I'm guilty. I do it. My first operator was without using any SDK. But if there is an SDK, it will make your life easier. So there are basically three options. The Java Operator SDK that also has a Quarkus extension and also has an integration with Spring. There is also a Python Kubernetes Operator framework, and also the Go Operator SDK. So those are three options that can create operators. They can scaffold the operator, that can give you some, avoid some boilerplate from your code. So at this moment, you can be asking yourself, okay, but how an operator looks like? Is it very complicated, or, well, do I need to work to do lots of things? Let's share. I will share with you. I think is this one. No, it's not this one. Probably is this one. Sorry. Okay. So here you have, hopefully, the Keycloak, in this case, Keycloak operator. We are working on it, but, well, it's a clear example for you to know what is an operator. Well, basically, this is it. We can have like the representation of that business object, that is Keycloak. It's a simple simple Java class with another Java class that represents which are the properties that the user can provide. in this case, number of instances. That's easy. Status, that it is a simple class to represent which is the status of the let's say the object. And then what we need is something that reacts to the movements or the changes in that object. So what we have is, in this case, with an annotation, controller configuration, we inject the Kubernetes client, and we have one method that is going to be called every time the object specified in the reconciler is changing. So either because there is a new, in this case, keycloak object created, or because there is a new update on that object, whatever. So what it does is basically, okay, you are creating this new object or you are updating this object. I am going to see which are the changes that I need to do in my infrastructure. And in this case, what we are doing is just simply calling a method that will deploy everything. It's a class that uses the client in order to create applications, to create deployments, or create anything, just to deploy the infrastructure for the application. And that's it. That's an operator. Nothing else than that. Then, using the SDK, what we have in the end is, well, it will provide several files. So it's going to create basically the representation of that CRD that I showed before, the keycloak CRD, with this YAML. So I have the YAML here with, do you remember the number of instances? Or do you remember the status? Okay, everything is here, but I didn't have to create anything. It's in my target folder. Or it even creates one file to deploy everything, depending on the target. It can be Minikube, OpenShift, or Kubernetes. In this case, as I'm working with Minikube, here we have the whole file created by the SDK with a service account, a service, a role binding, another role binding, another role binding, a cluster role, a deployment. So everything is there. You can configure all what you want, but you have all the methods, all the properties in those YAML files. You can even just simply deploy it easily, because with the Maven command, in this case Quarkus, is going to create everything, is going to push to the registry, is going to deploy into the cluster, as I showed before with JCube, a similar approach. So in this case, again, I haven't done anything Kubernetes-wise, no touching any YAML file, and I have everything created for me and even deploy it without me having to execute any kubectl command. Let's move to the last part of the presentation, that it is, well, this fancy thing that are kubectl plugins. A plugin is a simple, regular CLI application with a Kubernetes client. It's executable, and we could do it different approaches, but the easiest one is using JBound, an amazing tool that can use script Java files and create applications with that. It makes everything very easy, and in this case, you are going to see it's super easy, super fun. So let me show you the okay. So this is the plugin created with JBound. So in this case, we have dependencies specified here in the JBound way, even config properties specified here. The imports, we are using PicoCli as to the command line application. We are specifying a parameter. We have our Kubernetes client. And we have a run command. That what it is doing is just simply doing a call to the cluster, and either if we don't specify the namespace, it's going to do a call for everything, but if we specify it, it's going to filter by the namespace. And what it's going to do is just simply show me in Spanish the pods, the namespace, and when they were started. So let's try to do it. So Java JVang app install, the name of the application that is going to be installed in USR bin, and from which Java file. In this case, kubectl needs that your executable application has a name starting by kubectl, and it is in USR bin. So in this case, yeah, we are going to do this. Okay, install, fine. So let's see what it does. Okay, so it has shown us this pod from the default namespace. But if I do it the same from kube system, okay, now what I see is kubectl has executed this plugin that it is showing me the name of the pod, which is the namespace, and when it was started. That's easy. And it's less than 40 lines of code. So very, very easy and very fast to do a plugin with JVang. Totally recommended to take a look to this tool. So let's wrap up now. So my conclusion is that my daily work in cloud has been great with Java, because Java has a great community. It's easy to get help and to have libraries. There's code for everything. Can be used in most of all the Kubernetes parts. I have to say that I've been trying to find CNI network plugins or storage classes for Kubernetes made in Java, but I haven't found any. If you know any, please ping me and send me. Although the specs are agnostic of the language, so it should be possible to do them, I haven't found them. So I could say that Java can be used in all of the parts in Kubernetes. Also can be compiled natively with GraalVM. So then we have a huge performance that has comparable performance with Go and Python. So then there's the criteria to decide which language no longer is the performance. And finally, that in my experience, Java is more alive than ever. So this is the end. Here I put all the references in order to follow the different technologies and the code. I would have a big thank you for Mark Nori that have helped me reviewing the slides. Igor Domrev that has this blog post about Java versus Go comparative. Christoph Willemsen that has done kubectl plugin with Kubernetes post that helped me a lot. Also, Sebastian Blanc that already shared with me the code to do a kubectl plugin with Quarkus, and also helping me with some questions. So thank you very much to all of them that have helped me to do this presentation. And this is it. Thank you very much, and I hope it was fun for you, or at least that has started a flame of curiosity, sparkle of curiosity in you about all of these topics. Again, you can contact me with my Twitter account, my email, in my blog, or in my GitHub account. thank you very much. I will try to answer the questions. So, okay. One question was if I can go back. Sorry. One question was about showing can you show the Quarkus deployment? Can you specify? So I'm in which is the projects you wanted to share in the first demo? The first demo is about JCube. Okay, let me find the JCube. No, it is not. Yeah, the JCube. Okay. So I will share this window. Screen. Kubernetes. So what you want to see is which is the Kubernetes deployment, right? So in this case, what it is doing is having an intermediate deployment file that will help to create the Kubernetes file, or the other way around. So in the end, both are very similar. Here we have the service, and here we have the deployment, the Quarkus deployment. They are very similar and basically contain all the attributes needed in order to deploy the deployment to the cluster. And then there are okay. Is saying. Okay, do you think that with JCube I can completely replace Helm chart? To be honest, I've been working with Kubernetes for around 2 years, and I haven't used Helm chart at all. It's another approach using Helm chart, but I haven't needed. So no, you can deploy several things using JCube, but Helm, well, it does some of the things the same, but yeah, then you have Helm Hub or Artifact Hub, I think it is called right now, where you have several things deployed there. Well, in the end, it's different. JCube is basically helping you to create the artifacts and then help you to deploy. But with Helm, you can create definitely those artifacts and create infrastructure. So for instance, you can create operators with Helm charts, but basically not with JCube. You can create the infrastructure, and JCube will help you to create all those artifacts and to deploy them. But I would say they are not exactly the same. How does something like telepresence compare to JCube? To be honest, I don't know. I don't know how to answer this question about the telepresence. I'm not familiar with this concept. Sorry. Do you have any preference about Quarkus microprofile Spring Native based on their roadmap growth? Okay, is asking me if I have any preference about Quarkus microprofile Spring Native based on their. I would say that when it says microprofile, it means Micronaut. Basically, well, I would say I prefer Quarkus, but you need to test on your own. So I would say try them, and they have different approaches, but all of them are very interesting and very powerful. I prefer Quarkus, but yeah, it's up to you. My reasoning about Quarkus is I love the approach that it is behind, that everything is a standard library. There is basically almost no invention at all, so you still use all the standard libraries. And even if you want to code with Spring, you can still work with Quarkus using the Spring extensions. So you still use Spring code, but it's Quarkus who is doing the work. But it's my personal taste. Please go check those awesome technologies and experience by yourself. Can Jacob deploy to AWS? I don't know. If it's a Kubernetes cluster, so I think it's EKS, I assume. I would say yes. So once you are locked to the cluster, Jacob can deploy. But apart from that, I'm not sure. I don't know. Sorry. I see another question. How can I configure Quarkus in existing Spring application? Well, it's a matter of using the same interfaces, but then you are using different dependencies. If you are interested on migrating applications from Spring Boot to Quarkus, I recommend you to search for my talk, Spring Boot to Quarkus. You can find in YouTube, or I can share with you the slides. So and yeah, you will find how it is to, or even go to my blog, and there is a blog post in order to help you to migrate from Spring Boot to Quarkus, still using Spring interfaces. How do you manage JCube current Kubernetes context? I would say from outside JCube. So with JCube, you can specify which is the namespace that is going to be used, but the context, so the cluster where it is connected, I don't know if it's possible to be changed from JCube. I don't know. I usually change it from outside every time that I need to change the context. The context has the cluster and also the namespace. So yeah, when you deploy, you can specify. Now I'm mixing the approach of Quarkus or of JCube, but I'm pretty sure that you can specify the namespace when you deploy. In the case of Quarkus, this namespace can be added into the YAML files that are generated or not, and then you specify which is the Kubernetes client namespace that is going to be used in order to create those deployments. And is this incorporated in the Maven plugin configuration itself or externalized in some way? As I said, in order to change the context with JCube, I'm not sure. Sorry, I would need to check. I don't know. I'm pretty sure that the namespace, yes, but I'm not sure about the context. I don't know if there are any more questions. In fact, I'm very happy with all the questions. Oh, Marwan, you are very interested. That's nice. What would be the best way to include JCube in a development workflow? Meaning, would it go after running usual tests? Well, in fact, the tests, well, depending on which are the tests that you are talking about. If you are talking about integration test against a mock, yeah, you don't need those features that JCube is giving you. But if you are doing tests against a real cluster, then you need to deploy everything and then execute the tests. There is a way of doing this if you are using integration tests that are called in the verify goal. At least is what I was doing yesterday with the Quarkus approach. I have to be sorry for this, because sometimes I mix JCube and the Quarkus approach, and I'm not sure if all the features are in both places. Sorry. If you can send me an email, I will definitely try to invest time and get the answer for you. And for those of you that have made a question that I didn't know how to answer, please send me an email, and I will be more than glad to investigate and give you the answer. Naveen asks, when we shifting to microservice from monolith, what is the best practice to validate my app is worth for Kubernetes? Well, talking about, well, microservices, definitely, if you are going to microservices, there are several ways to deploy, but definitely Kubernetes is one of them. So basically, it's up to you to decide if you want to go to other approaches using VMs or Docker swarms or whatever, instead of using Kubernetes. But I would say that from what I've seen in my small experience, is that everything is going towards Kubernetes. So definitely I would give it a go, because you will have lots of implementations of the cluster. Also, you would have different cloud providers and lots of information and tools. So definitely going to Kubernetes is an option. And if you are in microservices, then Kubernetes is definitely a good option to go. I don't know if we don't have more questions, because we are, I would say, 3 minutes over the time. Thank you, all of you, to be here and be patient with my presentation. Hope it was interesting for you. Thank you very much.